So we are finishing off the last class's lesson. You are on page 24. So this question 3, it looks like you just accomplished something exactly like this on your quiz, so we'll go through this one quickly. With radius equal to 4 and height equal to 10, we're going to want to calculate the surface area. I just want to remind you that that height that they gave you, this vertical height, which is 90 degrees to the base, that height is used for volume, not for surface area. Okay? This is used for volume, not surface area. If you look at the surface area formula, there's no H. There is an S, which stands for slant. So that slant has to be calculated, of course, using the Pythagorean theorem, which is that blue line, that hypotenuse. Okay, you can find H using the Pythagorean theorem shortcut. Because it's the long side, we will add. Because it's the long side, we will be adding. And the two values that you have to add up are the height squared and the radius squared. So we have radius squared and height squared. This looks like the square root of 116. 10.77. You guys agree with that? Okay. And this is, of course, in meters. And then now we can jump into this surface area formula. Pi r is 4. Whoops. R is 4. S is 10.77. What was the third decimal? I usually take about 3 decimals for accuracy. 0? Okay, perfect. That's pi rs plus pi. And just a word on pi, please use the pi button on your calculator. Don't use 3.14. Okay, use the pi button. So then this would be 4 squared. And just in terms of confidence, I know some people are a little bit hesitant on math, but if you're good at your calculator, things do seem to get a little bit better. I can only demo on this one. So if I was to do this on mine, I would go pi, and then r was 4, and then s was the square root of 116, or you could put in that 10.770. Okay, plus second little hat here is the pi button, and then r was 4, and then the square button's right here, the square button. Is this what you guys are getting? Did you guys get that? Yeah? Okay, so 185.6. So again, I can only demo on this calculator, and I highly recommend you get a Texas Instruments, a TI. Typically you want TI 84 or better. TI 84 or better. So 185.6 is what we're looking for there. And the unit was meters, so the surface area unit, because it's two-dimensional, you'll have meter square. Any questions on that? Don't be afraid to ask questions. If I'm going too fast or if I'm going too slow, just let me know. Okay, the next one is a problem-solving question with algebra. Okay, so problem-solving with algebra. And the reason I know that is this style of problem is because you are being given the surface area. You're given the surface area. That last question we just did, even though there was a preliminary step, it's basically just a straight calculation. See, this is surface area, and that's what we want, and we have a formula for it. So, we have to do a little bit of algebra on this. And again, this is just something special to this unit that, to be honest, if I wasn't teaching this, I would have never even knew what this meant. Just this word here, remember sometimes, sorry, I just got to reconfigure this thing. This word here, is that working? Okay, that lateral surface area, please highlight it. And then I want you to put the word, just put omit the base. And if there was a top, you would omit that too. As if you, I don't know if you guys ever played football or rugby. You guys know rugby? What do they always have to do with the ball? They got to throw it to the side or back. So it's just the side. That's what lateral means. It's like laterally to the side. Okay? So we just want the sides. So all we care about is these triangles here. And it doesn't look like it, but it's a square. So all these sides are the same. So what does that tell you about the four triangles? They're also all the same. Different than the one on the quiz. The quiz was a rectangle bottom. So the triangles come in pairs. The front and back are the same, and the left and the right are the same, if it's a rectangle. But because this is a square, all four of those triangles are the same. So for the lateral area, the surface area is equal to 4 area of a triangle. Do you agree with that statement? Do you? What is that saying? For the lateral area, we have 4 faces. Do you agree? Okay. We can plug the 3,000 here because that was given. Surface area was given. And then we have 4 multiplied by, what's the formula for a triangle? Base times height divided by 2. Now comes time for some algebra, which I know some of you fear, but please just, it's like gym class. You gotta try it to see if you can do it. If you've never shot a basketball before, you gotta try, you gotta start somewhere, right? You might miss the first 12 times, but eventually you might get one. Okay, so let's take a look. How could we simplify this equation? Let's start with the left. Can you do anything to the left? No. Can you do anything to the right? What's 4 divided by 2? Okay, I think you could handle that, right? 4 divided by 2 is 2. Now what's the base and what's the height? The side length of the base is 50? They tell us that, right? So we can replace B with 50. And do we know H? No. What's 2 times 50? 100. So now we have 100H. Do you guys recognize this structure? 100 times something gives you 3,000. You could work backwards with division. Divide out what? Good, divide out 100. Hopefully you've practiced this lots from junior high. 3,000 divided by 100 should be 30, right? I'm going to just double check on my calculator because I'm nuts. 30. And then this is where some of you will get mad at me, which is understandable. What did we just solve for? Of what? Height of what? Height of a triangular face or height of the pyramid? Nope. It's the height of the triangular face, right? Because that's what we're calculating. So what we just calculated was this. That's what we just calculated. That slant is equal to 30. Okay? It wants the height of the model. And this is where reading comes into play, and patience and persistence and determination. Okay? What we actually want is this height. That's what we want. And how are we going to get that? If the whole base is 50, this little base is half of that, 25. And then all we have to do is a little Pythagoras on the 30 and the 25 to get the height h. What would be the Pythagorean shortcut for that? Addition or subtraction? Good, because it's a short side. So we're going to subtract. Which number goes first, the big one or the small one? The big one, because you can't be subtracting a small from a, or a big from a small. And that will get you the actual height of the prism. The square root of 275, is that right? 16.58, so 16.6. And our units are inches. Now for this, is it inch or is it inch square? Inch, because it's a height and it's one-dimensional. That's ridiculously hard. You'll never get a multiple choice on my test like that. Because it's, this algebra is difficult, and then on top of that you got to do a Pythagorean to finish it off. I could see though this question, just this question, this part of it, as a multiple choice. And it'll just ask you for what's the slant height. Or maybe they'll give you a volume of a sphere, and they'll give you the volume of the sphere, but they'll want you to calculate the radius. Okay, so let's keep going. Yeah, flip the page to day 5. This is where we're at, day 5. We're going to talk about volume. Volume is way easier than surface area. It's just formulaic. All right. Okay, let's take a look. So cone. For cone, you're going to need the radius, and you're going to need the vertical height. Okay? And you're going to find that the volume is much simpler to deal with, and that's nice. So the volume for a cone is going to be 1/3 pi r squared whoops, pi r squared h, which you can double check on your data sheet. I'll just have you scan your data sheet. Go find cylinder. Do you see cylinder? That's right underneath on your notes. Let's just quickly sketch that guy in. Cylinder has a very similar formula that uses the radius and uses the height. Again, which the height, just remember that it's always perpendicular to the base. So just put a note there. H is perpendicular to base. Okay, that's why you see those little square symbols, those little 90 degrees. That's these guys, these little squares. These little squares. Okay, heights are perpendicular to the base. My data sheet is telling me that the cylinder for volume is pi r squared h. Very similar, right? So what could you say? If the radius and the height were the same, how does the volume differ? The cone is 1/3 of it. You could fit 3 of those cones inside that cylinder. Okay? Wake up! Also, a word on these formulas. Let's take a look at the cylinder. What does this pi r squared represent? Area of a circle. So it's the area of the base multiplied by the height. That's a pretty standard thing for prisms. That's for prisms. Area of the base multiplied by the perpendicular height. Okay, so take a look at the prism. This is just the box. Remember, we draw 2 little rectangles like that, sort of overlapping, and then you can connect the edges. I'm going to shade in the bottom, aka the base. What is the area of that base? That blue base? Good. Length times width. Area of the base is length times width. If you look above, it's area of the base multiplied by the height. And what do we call the height? H. So to get the volume, it's just L W H. Probably the easiest one, by far. Now the pyramid, what do you think the pyramid will be? If the cone is 1/3 the cylinder, the pyramid is 1/3 the prism. Okay? And you can see that that goes right here. 1/3 LWH. Scan your data sheet. It's the third one down. 1/3 LWH. And which H is it, by the way? Is it the slant H? No. Good. So to draw this, draw a squished square. Find the middle. Go straight up. Connect the edges. And it's this dotted H that we're talking about. It's the perpendicular height to the base. Heights are always perpendicular to the base. Okay, right there. Height perpendicular to base. And then you're just going to love how easy this is. LWH 6, 8, 5 That's very easy. Again, please. 240. Now, what kind of units am I going to use? Cubed. So that's centimeter cubed. And just a word on that. Watch what happens. Centimeter multiplied by centimeter multiplied by centimeter. Centimeter cube. You guys okay with that? Centimeter times centimeter times centimeter, centimeter cube. Take a look at B. What shape is that? What do you need? Diameter or radius? Radius. What did they give? Diameter is 2, therefore radius is 1. Beautiful, you guys. For some of you, this is such a nice review. Yeah, area of the base would be pi r squared multiplied by the height h. Use the pi button. Good. So before I just give you the approximation, which is the decimal, you can actually give an exact value. What's 1 squared? What's 1 squared? 1 times 5? 5. So the exact value is 5 pi. This is called exact. When you put that in your calculator using the pi button, and you get 15.7 meters cubed, this answer would be called approximate. Any questions about that terminology? Yeah, because it's been rounded, it's approximate. The 5 pi is exact, because the decimals for pi go on forever. That's why I just use the symbol pi. So only these 3, you guys, and then I will give you time for homework and I will walk around answering questions. So about 10 more minutes, and then you'll have about 25 to work. Okay? Because it's been a lot of me up here, and I want it to be more about you guys. Take it. All right. Now we'll have a little bit more challenging volume problems, maybe some problem solving in here. They want you to calculate the volume of the pipe shown to the right. And the pipe is only about 1/2 centimeter thick. Okay, so there's a whole bunch of empty space in there. Does that make sense? It's a pipe with a whole bunch of empty space. It's only a little bit thick. It's a tiny bit thick. So to calculate the total volume, we have to do a subtraction. Okay, we're going to pretend that the cylinder is completely filled in. Let's just imagine that the cylinder was completely filled in. From the far edge to the middle, what would that radius be? 1/2 of 11 is 5.5. So let's go volume big. Pi r squared h 5.5 squared times 15. We'll have to subtract volumes. Okay, I got about 1425.5 centimeters cubed. Now volume small, the smaller cylinder, is the area, or pardon me, the volume that we want to remove. The volume that we want to remove is this dotted one. That's what we're going to take out. We're going to remove it from the larger cylinder that we just calculated. So what we need is the radius of this inner cylinder that's going to be removed. How thick are those edges? 0.5 centimeter. So you have 0.5 centimeter here, and you also have 0.5 centimeter there. Altogether, 2 halves make a whole. Plus this is 11. So what's that diameter? 10. The whole thing's 11, and we take off a half there and a half there. That leaves 10. What's the half of 10? 5. So that's the radius that we're going to use, a radius of 5. So pi r squared h, r is 5, and the height stays the same at 15. I got 1178.1. And I'm removing the blue from the black. So final answer would be 1425 minus 1178.1. And when I do this, I actually go into my calculator and I take extra decimals for accuracy. So I look in my history and I take all the extra decimals, and it ends up being pretty much 247.4 centimeters cubed. Okay. This would be volume total. It's the large cylinder minus the blue cylinder. Still pretty hot in my room. I know it's the morning's okay, but the afternoon's rough. Once it's no longer plus 25 outside, it'll be better. These south-facing windows are killer. Okay, this Toblerone bar, it's almost like the shape of a tent. You will not find it on your data sheet. This one is not on your data sheet. Good. So it is a prism. So you need to know this. You could even jot it down on your sheet. Please just jot this down on your sheet. The volume of a prism will be area of a base multiplied by height. And that's for all prisms. And remember, prisms have parallel bases and tops. They're the exact same shape, top and bottom. So like if this Toblerone bar was stood up on its end properly, then you would see it would look something like this. It's like a block of cheese or something, like in the TV shows. It's a prism because the triangle base is the same as the triangle top. Now the area of the base is the formula for a triangle. So what is the formula for the area of a triangle? 1/2 base times height. But I already have a height over there, h. So let's call this capital H. And then I'll times by little h. So which one's which? What is the height of this prism? Good. This 26, if you put it on edge, this is the lowercase h. So that's 26, the lowercase h. What's the base of that triangle? 4.2? So what's the only thing that we need to calculate? or figure out, what is this h here? What does this capital H represent? That's the height of the triangular face. Because we're trying to calculate the area of that face, and that uses the vertical height for the face. Is it given? What other information is given? What is this? Equilateral. So what is it saying about all three of those sides? They're all the same. So if that's 4.2, this is 4.2. Guess what we need? Your friend, Pythagoras. So if this is 4.2, what's this bottom side? Very nice, 2.1. And the Pythagorean shortcut, is this an addition or a subtraction? Good. That's over here, right? Yes, good man. So long side first, 4.2. Take away short side second with the square. And we will get this guy here, which we're calling capital H. 4.2 squared, take away 2.1 squared, square root that 13, it's about 3.6. Does that 3.6 seem reasonable? It's shorter than the hypotenuse, which is 4.2. So yes, it seems reasonable. I need to slide that value of 3.6 right here. 1/2 base times triangle's height times prism's height. Final answer of 198.6 centimeters cubed. My calculator said 596 in the decimals. And then you can see here it says nearest hundredth, so I got to put 2 decimal places. I know it's hot, only one more to go. I'll turn the fan on for you guys, open some windows. Good, this last one is problem solving with algebra. Remember we did one to start the class like this? How do I know? Because it's giving you the volume. The shape is cone. So as I read this, I see cone, and then I go to my formula for cone, and it's like 1/3 pi r squared h. Though, and again, I don't know what kind of habits you guys have coming from junior high. We don't want to be writing x's in here to show times. We just want to put the variables and the numbers next to each other. That means multiplication. This is all, if you want, you can put little dots in here to represent multiplication. All right, let's try to fill in what we know. Where can I put this 8? H. Because that is the cone's height. This question would be really nasty if they gave you the slant height. Then you would have to find h with Pythagoras. But they just gave us h, so that's nice. They want us to determine the radius, so r is unknown. And in fact, I will use a different color for r, just to demonstrate that that's what we're trying to isolate. And then we got a pi in there. We got a 1/3. What's the volume of the cone? 300. All right. Algebra. R needs to be isolated. Right now, we all have these timeses in here. So what do we have to do? Opposite of times is divide. So I'm just going to divide the 8 first. I'm just going to divide out 8 on both sides. And now I have 37.5 is equal to 1/3 pi r squared. Now, here is something that you can decide for yourself. That 1/3, you can divide out 1/3 if you so choose. What's the opposite of dividing out 1/3? Heard it? Multiply by 3. Do you see how the 3 is downstairs on the right? So it goes upstairs on the left. How do you guys feel about that? Okay, you could also divide out 1/3. Dividing out 1/3 is the same as timesing by 3. Where does that pi go? Where is pi? On the left or the right? Upstairs or downstairs? On the right, pi is upstairs. So pi needs to be divided out just like the 8 was. So pi has to come down here. And you must divide by the pi button. I got 35.8 equals r squared. And then you got to finish this off. We've talked about this a few times, so finish it off. How do you get rid of this? Square root. Okay, so I got about 5.98. Okay, you can see the assignment is given right next to you, plus yesterday's or Friday's assignment. Okay, so you have about 20 minutes to work. Please use your time wisely.